Hello everyone. In this video lecture, now we are going to see about the online tool Tinkercad. First, you need to create account in it. Tinkercad.com is the website, and go to home. And from here, you can see designs. In 3D, nothing is there. In circuit, some of my designs are already available. If you want to create new, from go to designs, and from here, click on create. Here you can see 3D design, circuits and code blocks. We are going to work with circuits. Yeah, this is a new page created, and here in components it is basic. You may select all also to get more components. Yeah. Now initially I need is Arduino Uno. Yeah, if you just click on Arduino, here not only the microcontrollers, here you can see that already many basics are have been done by others and it is uploaded and you can even access those. But we need to learn from scratch. You can select that, drag and just drop it, it is enough. And here you how you can give connection is by clicking on this. From here you can take the connections. Yeah, and now we are going to perform blink LED with Arduino Uno. For this, I need hardware components. One is breadboard small I am selecting. Yes. Next, for blinking of LED, one I need is LED. Yeah, RGB LED is different and normal LED is different. We are going to work almost in most of the experiments with normal LED, red color one. And you need to place it on breadboard exactly on any two dots, but don't place on these two lines and these two lines, as those are belongs to ground. Yeah, our LED is ready. Now to oppose the flow of current, we need resistor. Place that one also. Yeah, here we are having the bulb is having two pins. One is the anode and cathode. Anode means plus, cathode means minus. In the tool, you can see that the bending is positive and the straight is negative. And now just get that resistor onto your breadboard. Yeah, click on the resistor and from here you can rotate it. Make it horizontal. Move all the components near for easy accessibility. Now I am going to place this resistor here. It opposes the flow of current. Yeah. Now our basic thing is ready. Now connections. Remember that while in general we can use any color, that does not matter. But when others, for example, I invented a small application, hardware device. Let me think any remote controller or anything. For example, our device is spoiled. When the client visits to any of the stores, means he directly can't come to the founder and ask that you can repair it. He visits any of the repairing shops, right? In that store, when he visits, the person who tries to repair it, he need to understand what's the problem and how to rectify it. For the understanding of many people, we are going to use it. And coming to first, we will give the code and then we will give the connections as per it. Here you can work with three things. One is blocks and text. Only text is nothing but for entering the program. Here the default code for LED underscore built-in is nothing but digital pin 13. Here already the code is available. LED built-in is nothing but, as I told, the digital pin 13. Now let me give the connections for easy understanding. Wait just a second. Let me drag it to middle. Yeah, in this tool, this is the zooming problem will be a lot. Yeah, I have selected red for the positive connections. Remember that LED built-in is nothing but digital pin 13. Only for that one we are going to use. I will also explain the code. First, you know, observe how I am giving the connections. And minus you can give to either this ground or the ground. Here two more grounds are present. Any of the ground is fine. Yeah. If you give such cross wirings, it may be difficult to understand where exactly you are mapping. So by moving here, where you get like origin like four lines, at that division gives you the perfect lining. And now coming to coding part. Here, pin mode is nothing but you are setting the pin value. Nothing but LED built-in indicates the digital pin 13. I will also change it and explain. That one we are using as output. How our output should be is going to define here. Since we are working with LED, it is nothing but digital, right? And we are working with digital pins. So we are using digital, right? Digital, right? First, the LED will be high. Yeah, this is the milliseconds. Delay function uses the milliseconds. We are also having one more delay function regarding time delay, that is delay microseconds function is also available in Arduino. Yeah, now I am just executing it. Nothing but click on start simulation. Yeah, you can see for every 1 second the LED is blinking. Now let me change by taking some of the variables. I'm stopping my simulation. Here, let me, as you know, in many programming languages, as I said, this is similar to C++. I'm going to use in the same way. Now remove LED built-in and I am going to give LED. Same here also you need to make changes. What you have mentioned in the setup, that only regarding that you need to mention in the loop. We will also see what are the variables, constants, and all the some of the important functions available in Arduino IDE in the next lecture. But for now, just I am executing how you can work in Tinkercad online tool. Yeah. Now, if you start simulation, yeah, you can see that LED is not blinking. The reason is it is connected to pin 13. You may get out that previously we did not mention the number 13. Here you can see L, right? Here in this tool it is not working properly. But when you work with the real Arduino hardware part, whenever you use the term LED built in along not only the LED, this L is there, right? This LED is linked to digital pin 13. That will also uh, blink as per this LED. Now we are going to change this one. Use the delete for deleting. Since it is positive, I am using red color. From here, you need to go to digital pin 3. Yeah, it is approximately straight. Now I am starting simulation. You can see now the blinking is coming correctly. This is how we are going to work. And whenever the power supply is there, automatically few LEDs on Arduino gets on. This is how we work in the Tinkercad tool. And similarly, let me show you the execution of buzzer also. Just you can delete this all. Search for the term buzzer, piezo buzzer. There will be no code difference for LED and this one. Same positive you can connect to digital pin 3. For negative, let me use black. Negative to ground. Now click on start simulation. Yeah, here you can see some type of vibration is coming, right? Hope you all have noticed it and heard the sound. This is how buzzer works. Now, similarly, we are going to see with real hardware components in tomorrow's lectures. But be ready by installing the Arduino IDE if you are working with hardware components. If you are unable to get the hardware components, or you are unable to afford, then you can use this free online tool Tinkercad. And I'm also going to provide the provide the link of this Tinkercad in the description of video. Thank you.